Now, using the same velocity time graph, how do we determine the displacement covered by the object? Okay, you first have to recall calculating the areas of regular shapes. If you are not able to recall how do you calculate the areas of regular shapes, you can pause this video, go back to your lower secondary school days and read up your maths textbook to determine how to find areas of regular shapes. And then come back to this video. Okay. Now, using the velocity time graph, we now need to determine the displacement of the moving object. But first, before I dive into that, there's this common misconception that students can use this formula, velocity equals displacement over time. But why is it that this formula cannot be used now? In order for you to understand that, you have to understand for this formula to be applicable, what is the condition for this formula to be applicable? Okay, I think your primary school teachers could have explained it to you, but perhaps because you did not apply this idea throughout, you may have forgotten it. I'll now spend some time reviewing it. Okay, for this formula to be applicable, the condition is that velocity must be constant. Velocity must be constant. Now, if you look at the graph, right? When time equals 0, velocity equals 0. When time equals 2 seconds, velocity equals 1 meter per second. When time equals 4 seconds, velocity equals 2 meter per second. You can see here, velocity increases, is not constant. Okay, therefore velocity equals displacement over time is not applicable. Okay, you cannot apply this because velocity is not constant. Right. Okay. Next, we'll proceed on how to determine the displacement using the velocity time graph. Okay, how do we determine displacement using velocity time graph?